Today we're interested in the question of whether or not there can be involuntary unemployment. I want to begin with just reminding you of the classic model of wage determination. We have some upward sloping labor supply function, meaning the higher wages that are on offer, the more likely people are to want to work, the more people will want to work. And then we have some downward sloping labor demand. Cheaper labor is, the more of it employers want to use it. Recall the labor supply function comes off of the individual's utility maximization problem, where they're weighing the marginal utility they get from leisure against its opportunity, against the opportunity cost of leisure, which is the wage they can earn in the marketplace. Likewise, labor demand comes off of the shape of the firm's production function and the problem that they're facing of how to produce output while minimizing costs. So in this particular setting, you see we wind up with an equilibrium where everyone that wants a job has one, and the wage is the wage that makes sure that that statement is true. The kind of classical walkthrough of this is to say, well, if wages are too high, if they're above market clearing, so maybe if they're like up here, you've got more people that want to work than employers want to hire, and so consequently, someone who doesn't have a job will take a wage for epsilon less, and so on until you get to market clearing. Now, it's important to remember that the lack of unemployment just means that at the wages that are on offer, everyone that wants a job has one. There'll still be people who aren't working. The key reason and key insight in this is that, well, they're not working because they don't want to work at the wages that are on offer. The other things they can do to spend their time are just better uses of their time. This particular model of unemployment that we're going to develop is one where individuals can't bid down wages because they have some underlying capacity constraint. This is like a subsistence wage model, nutrition efficiency wage model, all different names that could apply to the same basic model, that you can't get down to wages low enough to clear the markets, because then at those low wages, people just wouldn't have the capacity to work. So it's built on something that we'll call the capacity curve. Typically, we might draw the capacity curve in a space between kind of work capacity, so how much you can actually work, and food intake, how much you can actually, how much food you take in. And the idea behind this model is that at very low levels of food intake, you really aren't able to work very much. And then at some point you kind of get your minimum amount of food that you need to be able to eat and all your basic bodily functions perform well, and you can really start then very quickly turning additional calories into output. And at some point, your ability to turn those calories into output diminishes, and you could even imagine some part of the distribution bending down where you've got so many calories now that you've consumed that you actually aren't able to work very effectively. We won't worry about that too much in the population that we're studying here. And this is our basic capacity curve, the kind of basic respiratory, heart, living functions. Then you can sort of take off and really start producing, but at a diminishing rate such that at some point you kind of then top off. All right, so that's our capacity curve. So this relationship between work capacity and food intake will eventually drive the individual's labor supply function that they're faced with. Before we do that, it's not very helpful to have food intake on our running axis, as that's not going to be something either that we directly observe or that people get paid. Instead, people tend to bring in income. And what we're going to take advantage of is something called, the angle curve. The angle curve looks at the relationship between the food budget share and our favorite measure of income. And basically what we see is that as you get richer, the share of your income that you end up spending on food declines quite a bit. In most low-income populations, we'll typically assume that the food budget share is about 70% of your income. So what we can do then is we can plot our capacity curve in this work capacity times income space by merely remembering that food intake is equal to 0.7 times income. And therefore, what we'll end up doing going forward is we will simply write this capacity curve as not food intake, but instead income. Now, to put a model together that tells us how the wages people are receiving relates to how much labor they can offer, we need to first add wages to this picture. So we're going to have that capacity curve, which is the underlying constraint on people's ability to commit to working for lower wages. How do we draw wages? Here we're going to assume that we're in a piece rate world, meaning that for every unit of work you do, you get a fixed amount of income back. So if I pick 100 apples, I'll get 100 times what I would get if I just picked one apple. So it's a constant piece rate. And this is not too bad. You know, a lot of day laborers are paid on a piece rate basis. Much of agriculture during harvest season, which is sort of the most busy season, gets paid on a piece rate basis. So this might be one individual wage schedule. The slope of that line is simply the piece rate. And notice that for a given amount of work, if you're paid more for it, that means you'll get a higher level of income, so that higher wages rotate the piece rate down, and lower wages will rotate that line up. People get confused by that because they always want things going up to be higher. It's not the case here, given that it's between the amount of work that you do, measured in output, and income. Now we're ready to put together that wage schedule with the capacity curve. Begin by drawing my capacity curve. Whoa. And then we'll have one example. Let's pick a particular piece rate here. Oops, I wanted that third intersection, so I'm going to have to cheat and fudge that on a little bit more. Okay, so you can see that there are 1, 2, 3, 4 intersections between the piece rate and the capacity curve. Okay, so how do individuals decide how much to work? In general, they're going to, in this setting, we'll just have them simply maximize income. We always want to simplify things in economic models, and in this case, we'll give them a really easy objective function. They want to maximize their income, that's all they care about. So in this instance, obviously the place where they're most able to maximize their income is when the capacity curve is intersected with the piece rate at this point. We'll call that C. Mark these A, B, and C. Okay, so maximizing income means that you would produce some output amount, call that output C, and you would get some sort of income, we'll call this income C. Okay, so that's a couple things to point out here on this picture. Number one is, let's suppose that we were at point B. Okay, so if we were at point B, notice that epsilon below point B, the amount of output that would be required for a certain wage on the piece rate scale isn't available to the individual because their work capacity diminishes. Okay, so kind of below point B, individuals really couldn't work for a little epsilon less wage. They just don't have the capacity. Now, that's not true for point C. For point C, they could work for a little bit less. their capacity curve is still above their income. And that would also be true, between A and the origin axis, that they could work a little bit more. Next, we want to think about the ability to engage in that kind of equilibrium logic where people build down wages until the market clears. So the upshot of what we're going to say is that tangency between the wage rate and the capacity curve is the kind of lowest wage at which people can then credibly supply wages. We'll begin there kind of talking through the easier examples of C2, of C1 and C2 as we've drawn it. C1 here is the exact same picture that we saw before. We have our capacity curve in green. We have our equilibrium. We have our offer, our wage, piece rate wage, where C1 is the income maximizing amount of labor and output that you can achieve. If wages were a little higher, we could see C3 would be a possibility as well. And we can see at C2, the amount you can supply is just right there at that tangency between the capacity curve and the wage offer that's in place. Now, there's no reason why we're going to wind up with the wage offer of C2, because wages are determined as a combination of supply and demand, and I haven't talked to you at all about demand. But here, let's just talk about supply. Let's say that the wage on offer is C1. Well, and let's say that I'm at C1, okay? And I'm working very happily, and there's someone next to me who has the same capacity curve that I do, but isn't employed. Well, they could say, hey, I'll work for a little bit less. So that would be epsilon less than C1, and they'll take my job away because they're working for a little bit less and they're still able to produce because of their capacity curve. So on and so forth, we get that market clearing logic all the way to 6.2 where there's just a tangency. Now, if I have a job at C2 and someone offers to work for epsilon less, well, if they have the same capacity curve as me, they're working at epsilon less than C2, they're going to have to drop all the way down there. They really can't work effectively at all for wages less than C2. What this is going to mean then is that when we plot our labor supply curve, which is the link between the wages that you have and how much you're working, there'll be a discontinuity right at kind of C2 that leads to a massive drop in the amount an individual can possibly work if wages are a little bit below that. Now we want to think about how we generate individual labor supply. Here we're now graphing the piece rate, so that wage that is on offer against the amount that an individual can supply under this assumption that people are just working as much as they possibly can. We mentioned that piece rate C2 before, and recall it was at C2 where individuals could no longer credibly supply much work if the piece rate were at all below C2. So what that means then is below C2, effectively we have very little in the way of labor that is available. And then above C2, individuals can produce a lot more labor. And we'll notice that capacity curve was curved so that labor supply wouldn't be a straight line. There'd be some curvature to it. So we can say something like this, so that we wind up with some individual labor supply curve, which just comes off of that intersections of the capacity curve with the piece rates that are potentially offered here. And here we're drawing kind of with a full set of piece rates. Now, what we're wanting to do is figure out market clearing, and you go from individual problem to the market problem by aggregating up across everyone. So next step will be to look at wage determination after we add together everybody's individual labor supply and add together labor demand. Here now we're plotting wages against the total aggregate labor supply that comes about just through adding up all those individual labor supply curves. And again, we have this sort of discontinuity at C2, or epsilon below C2, we can really not offer very much work. So let's consider 3 different labor demands. Okay, one labor demand, sort of your classical labor demand model, is one where labor demand is very high, at each wage that's on offer, and then you're kind of looking at what really just looks like a classical labor supply wage determination problem. Labor supply is upward sloping, labor demand is downward sloping, we get a market clearing level of wages and employment. We can also have really low labor demand, where we still have market clearing. Basically, people effectively can't work because there's just, wages, there's so little employment, equilibrium wages are so low that no one's really able to credibly supply work. So again, neither in this very low or high or normal equilibrium do we have involuntary unemployment. Everybody that wants a job has one, given the wages that are available. The interesting case is this space in between. Let's say we have labor demand like that. Well, now in this instance, what are equilibrium wages? They're C2. What's equilibrium level of employment? Well, it's the amount of labor that's demanded at C2. Notice how many people want to work at C2. Well, it's a lot more than employers want to employ. So we have this whole group of individuals who are wanting to work at the wages that are offered but can't. And the usual market clearing logic doesn't work, because if I offer to take a job epsilon below C2, in the end I can supply very little labor because of my capacity curve, and so I wind up way, way down here, which from an employer's perspective is just way too little. So with that little amount of labor on play, in labor demand such as it is, they would offer a very high wage rate. Well, then at this very high wage rate, a ton of people want to work, far more than they want, and so market clearing logic gets us down to C2, back to C2, but where we still have equilibrium unemployment. So that's how we can generate unemployment when there's this underlying capacity curve. People want to work, but their biological capacity to produce work at such low levels of consumption limits their ability to get to market clearing.